Alright guys, in this video I'm going to talk about solving problems with proportions and explain to you what a proportion is. And you really need to memorize this idea because it's going to be appearing the rest of the year. So let's go ahead and get started. If you look over, I have this box, and in that box are 6 donuts. So we can write this ratio of boxes to donuts. 1 box, 6 donuts. And then each of these are equivalent ratios. They're all equal because they can all be simplified to 1 over 6. So if you have a table that contains equivalent ratios, then each one of these is equal. That means that these ratios and these rates, 1 to 6, 2 to 12, 3 to 18, 4 to 24, they're all equivalent. That means they form a proportion, or they have this condition of being proportional, which means that it's a statement that says two ratios or rates are equivalent. They're just equivalent rates. So whenever you have two rates that are equivalent, they are proportional. There's a couple of ways that you can solve these types of problems, and one of them is to solve using equivalent ratios, but sometimes you can't do that and you have to find a unit rate and then solve using equivalent ratios. And here's what it looks like. I've only had 2 problems. I want to point out this is very important that you have this out. This is your template. This is what we're going to do, and you should have everything labeled. So these are the labels in Word. Let me read the problem. Vincent wants to enlarge a photo. It's 4 inches wide and 6 inches tall. I'm just going to kind of sketch that photo right over here. So it's 4 inches. I'll put the 4 inches wide here and 6 inches tall. Well, we'll keep the tall even though it could be length and width. The question is, the enlarged photo keeps the same ratio. So how tall is the enlarged photo if it is 12 inches wide? So we're going to have a larger photo. Here it is. But this one is 12 inches wide. Okay, so we come back to the table, and usually the labels follow the number. So this is about 4 inches wide. So we're going to put wide here and T for tall. And this is 6 inches tall. And these are the labels that we're going to use. They usually not always follow the number. So let's go ahead and write that ratio in 4 inches wide to 6 inches tall. And the question is, we're going to make an enlargement. Vince is going to make an enlarged photo that is 12 inches wide. So it's important that that 12 go on the line with the wide, so it goes up here and not on the bottom. Our job is to find out what the corresponding or matching value for how tall it is. So we can look at a relationship, proportional relationships. We look for a constant factor. So we can multiply this top number by 3, and remember, if we can multiply the top quantity by 3, we can also get a matching or equivalent ratio by multiplying the bottom number by 3. So that means 3 times 6 is 18. That means that the height or the tallness of this second photo will be 18 inches. And that is how we do it. And this was a pretty easy one because we just had to find an equivalent rate. Not always is that going to be the case. And here's an example of we're going to need to use a unit rate. So I've created 2 different scenarios here, or 2 different tables, so that we can work the first one and then use that information to solve the problem. Here's what it says. In a repeating musical pattern, there are 56 beats, and here's the label, 56 beats in 7 measures. Okay, so this is about beats, and you don't have to write out the words, but B and M for measures, we can put that out there. So this is 56 beats in 7 measures. How many measures are there for 104 beats? Now, it would really be difficult for us to calculate that, put that 104 and see what that factor is. So what we're going to need to do in this case is go ahead and find the unit rate. Let's find out how many beats in 1 measure, and then we can isolate that and solve this problem. So to get to 1 measure, I'm going to divide this bottom number by 7. So if I do that, I have to divide the top quantity by 7 as well. And 56 divided by 7 is 8. So that means in 1 measure, there's 8 beats, or 8 beats per measure. So we're going to come back over here and use that information. This is about beats in measure. I'm going to take that and apply it over here. 8 beats in 1 measure. The question is, there's 104 beats. And we're trying to find out how many beats there are. So we're going to have to do a little bit of division, and this is why it's called a multi-step. Divide that by 8. 1 and 8. 2, 4. 2, 4 down here as well. When we get to 0, stop. Make sure you get to 0 as well. Hey, that means that there are 104 beats in 13 measures. So this would be an example where you would have to find the unit rate and then use that unit rate to make a prediction. Sometimes when we make a prediction, we need to divide to find out what the factor is. So this was multiplied by 13 up here, and this is by 13. And it's critical that we figure out what this factor is, because we're going to need to know that and apply it, and it just takes a little bit extra work. So this is considered a multi-step problem. It's completely doable. Alright guys, those are just the two types of problems I wanted to talk to you about. These are the type that you would see on an assessment, so be extremely familiar with them. Good luck. We'll see you in class.